Today's topic is integration by parts. So if you can recall from our discussion in differentiation, one of the rules of differentiation was the product rule. We have discussed this rule in another video. So if you want to look at that video, please go and have a look at this link here, and you'll be able to see what we have discussed on that topic. But anyhow, I'll go on and write what that rule states. So if you have two functions, product of two functions, let's say f of x and g of x, okay, and both dependent on variable x, right? So the derivative d by dx of the product of the two, f of x, g of x, so this is given as d by dx of f of x times g of x plus d by dx of g of x times f of x. So that derivative is only for f of x, and in this case it's only for g of x. Now we can go ahead and simplify this. So let's assume f of x is u, okay, and g of x is v. For the sake of simplifying that line there, so you have by dx of, because f of x is now u, we can write u times v, that equals dy dx u times v plus dy dx v times u. This was what we called product rule. Yeah, so the derivative of the product of these two functions is the derivative of the first function times the second one plus the derivative of the second times the first function. Okay, if we take the integral of dy dx u times v, okay, dx, so this equals integral of u d by dx v dx plus the integral of v d by dx u dx. So what we are looking at is the integral of a derivative of a function, which is the function itself. Okay, so in that case, in this side we have u times v, so this is equal to, is integral of u d by dx v dx plus the integral of v times d by dx of u dx. So finding one of the integrals, u dy dx of v dx equals, we are considering this part of the equation is what we're looking solution for. Now we have taken this to the left side of the equation, so we can bring u times v minus the integral v d by dx of u dx. Okay, yeah. So we call this integration by parts. Okay, let's assume the following. You are given product of functions. Okay, so you are given product of functions. So let's say those functions are h of x and L of x. So we have two functions, h of x and L of x. So in this case, the objective is to find the integral of h of x times L of x dx. So this is now what is required. Now, what the rule of integration by parts tells you is that you're considering that this part of the function is that part of the function over there, and the items inside the integration are u and dv by dx. Okay, in this case, so you're assuming one of this is u and one of this is dv by dx. Okay, then so therefore we can go on and assume our u can stand for h of x. So this means that immediately dv by dx therefore is L of x. Okay, you can either assume this, either this, or you can also assume u to be the other one, L of x, u equals L of x. So immediately dv by dx is h of x. Okay, all right. So if you take one of these assumptions, rewrite this given problem in this integration by parts form. Assume that we have taken this assumption. Okay, so where our u is h of x and our dv by dx is L of x. Okay, L of x. Okay, so if you look at each of the entries, so u is assumed and dv by dx is also assumed to be L of x. Now the rest to find is, okay, in this u is also the same u. V is not yet addressed. Okay, so v is not yet addressed, but du by dx is also not yet addressed. Let us do that. So if u is h of x here, so du by dx is the first derivative of x, okay, of that function. And if dv by dx is L of x, so v should be the integral of L of x. Okay, L of x. So we're looking at finding a function or an expression. That function, when you derive it, will give you that L of x. Okay, this L of x. Okay, so let's have some example. Okay, and then find the integral of x e raised to x dx. Okay, what we're trying to achieve is writing this in terms of these two entries in the integration, which are u and dv by dx. So u and dv by dx. Okay, so what's u? What's dv by dx? It is always going to be one of these. One of these will be u, the other will be dv by dx, or you can assume that to be u, the other to be dv by dx. The choice of that assumption relies on so in the case of u, whether you can easily find that part du by dx, and in the case of dv by dx, it should be then easy to find what v is. Okay, so what do I mean? For example, if I now choose u to be x and dv by dx to be e raised to x, all right, then my task is then to find what v and du by dx are. So in that case, now what is du by dx here? Du by dx is, that's the derivative of x, which is 1, and that's easy. And also the other task is to find what v is. So we know that the derivative of e raised to x is e raised to x itself. Okay, so if I put e raised to x here, so dv by dx is going to be e raised to x. Okay, in other words, okay, find a function when you derive it will give you that equation, okay, or that expression. So now our job is done. We have u, so that's fine, that's taken care of, and we have dv by dx, so that's taken care of, and we have du by dx, so that's taken care of, and we have finally v, okay, which will take care of v and that for us. So everything is now defined, and it's easier to then go in and solve that problem over here. Okay, so now integral of x times e raised to x dx. Yeah, we assumed u to be x, so therefore du by dx is 1, and we also assumed dv by dx to be e raised to x, so this will give us v to be e raised to x. Okay, so now let's go on and remind ourselves what that rule of integration by parts is. Integral of u times dv by dx dx, this equals u times v minus integral of v times du by dx dx. Okay, so this is the so that's the rule of integration by parts. Okay, so we're going to apply this to our problem here. Okay, so we can write now the integral of u is x and dv by dx is e raised to x dx. So this is the problem we're aiming to solve. That equals u, which is x, and v, which is e raised to x, minus integral of v, which is e raised to x, times du by dx, which is 1 dx. Okay, so what we were doing was just relating this in terms of the defined variables based on that assumption. Okay, so this is fairly easily solvable. So the integral of x e raised to x dx is therefore equals x e raised to x minus the integral of e raised to x is e raised to x. Because this is indefinite integral, we can always add constant, because the derivative of a constant will be 0. If you wish, you can further simplify this line by taking e raised to x as a common factor, so x minus 1 plus constant. Okay, so this was easy. So let's write now example 2. Find the integral of ln x dx. Okay, we are required to apply the integration by parts method. So we quickly understand that to apply integration by parts, we need to have at least a product of functions. Okay, so in that case, we'll rewrite this in the following way. Okay, so if I go in and write integral of 1 times ln x dx, all right, so this is equivalent to our previous function. We can go on and solve this now. As the first thing to do is to always understand that we'll be looking at finding u and dv by dx. Let u be ln x, okay, and dv by dx be 1. So what is du by dx? This is 1 over x. Okay, to find v, find a function that when you integrate it will give you 1. So this is easy. This is x. Yeah. So now let's substitute those known variables into our integration by parts formula. So that will be integral of u, which is ln x, and dv by dx is 1. dx is equals u times v from here. So u times v, or u is ln x, and our v is x times x minus integral v, the integral of v. So our v is x. So mind you that our v is x here. So integral x du by dx is 1 over x times 1 over x dx. Okay, this is x times ln x minus integral of x times 1 over x. Okay, that will divide and we'll have the integral of 1 dx. Okay. So this will be x ln x minus x plus constant. If you take x as a common factor, this will be ln x minus 1. Okay, so plus constant. All right. Okay, so we can choose constant to be 0 because we don't have any other enforcing condition. So if you choose c to be 0, so this will be the integral of ln x dx can be x ln x minus x. Okay, so by taking this example 3, let's try to see that assuming u to be x and dv by dx to be ln x, or the other way around, which is assuming u to be ln x and dv by dx to be x, will result in the same outcome. Let's start by assuming u be x. Okay, so then du by dx is 1, and this will leave us with dv by dx to be ln x. So v is from this integral of ln x dx. And in the previous example, example 2, we have seen that this is equivalent to x ln x minus x. Okay. So so now let's use this and try to solve this problem. Okay, find its integral. This will be integral of x ln x dx equals u, which is x, times v. So our v is x ln x minus x, minus the integral of v times du by dx. So integral of what's v? So v is x ln x minus x times du by dx, which is 1 times 1 dx. Okay, now I can continue from here. I can cross multiply this. That will be x squared ln x minus x squared minus, and I can use the linearity of integration and integrate these two entries independently. So this will go on being the integral of x ln x dx plus the integral of x dx. Okay, so now this will be x squared ln x minus x squared minus the integral of x ln x dx plus integral of x is x squared over 2 plus constant. I'll choose that constant to be 0 for now, and x squared x minus x squared plus x squared over 2 minus the integral of x ln x dx. Now you can see that this item is pretty much this item here. So if I bring that to the other side of the equation, what I can have is I can go and write 2i's of the integral of x ln x ln x dx equals x squared ln x minus x squared plus x squared over 2. So therefore the integral of x ln x equals dx equals, so that whole expression divided by 2. So this will be x squared ln x minus x squared plus x squared. So this will be divided by 2, and because we have 2, 2 times 2 will be 4, so divided by 4. Okay, so this will be x squared over 2 ln x minus half plus quarter. This will be minus quarter, that's x squared over 4. Okay, so we can end here, or we can just go in and take that common factor, x squared over 2, so that will be ln x minus 1 over 2. Okay, so that is the solution for integral of x ln x dx. Okay, that's our solution. let's just call this case 1. Sorry. So in the second case, case 2, so we say that we'll be assuming this time u to be not x but ln x. So remember, that is our original problem. Okay, so u to be ln x and dv by dx to be x. So this time du by dx is 1 over x, and from this v should be x squared over 2. So therefore dv by dx will be 2. Now let's do the same again. Okay, insert this in our integration by parts formula, which is the integral of x ln x dx. So this equals u times v. So our u is ln x this time times, and our v is x squared over 2 minus integral of v times du by dx. So the integral of v, which is x squared over 2 times du by dx is 1 over x, okay, dx. Okay, so this equals x squared over 2 ln x minus, and that expression will be the integral of x over 2 dx. Okay, so this is equal to x squared over 2 ln x minus, so the integral of x over 2 will be x squared over 4 plus constant, so we'll assume that to be 0. So this equals, if we take a common factor, that will be x squared over 2 times ln x minus 1 over 2. Okay, so we're saying that this is equal to the integral of x ln x dx. Okay, so now you can see that making the right assumption, okay, has a great significance in simplifying the steps taken to get the solution. So in this case, or the consideration we have made in case 2 has significantly decreased the steps that is required to find a solution. Okay, thank you very much for attending today's video. My hope is that you will benefit from this video. If that's the case, please like it, share, and most importantly, subscribe to my channel so you will not miss any videos in the future. Thank you very much.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.